Hello, today we're going to talk about Lewis diagrams. So Lewis diagrams are the way that we represent covalent molecules. Okay, so we will usually use dots to represent electrons and lines to represent bonds. Now, to start out with, we're going to need to use Lewis symbols. So if we remember from a couple sections ago, there's a shortcut for determining the number of valence electrons. We can do 1, 2, 3, 4, 5, 6, 7, 8, with the exception of helium, which only has 2. Transition metals have weird numbers of valence electrons, but you're not going to typically be using metals at all because we're doing covalent molecules. And then when you're doing that, you would draw the valence electrons around the symbol for the atom. So if I have something like oxygen, oxygen has 6 valence electrons. You would go 1, 2, 3, 4, 5, 6 for oxygen. Always go in a circle, 1 on each side before you double up. Something like chlorine. Chlorine has 7 valence electrons, so you do 1, 2, 3, 4, 5, 6, 7. And that would be the Lewis symbols. Now, if you're doing a really simple covalent molecule, you can start with the Lewis symbols and just connect the electrons that are by themselves. So what that would look like is something like NH3. Okay, so you would draw 1 nitrogen and 3 hydrogens. Nitrogen has 5 valence electrons, 1, 2, 3, 4, 5. Hydrogen has just 1 valence electron. Now, whenever you have a pair already formed, we call that a lone pair. So you can't do anything with the lone pair on the nitrogen. It's already partnered up, can't form a bond. But we can connect the dots on the other ones, so something like this, and this, and this. So we can form those 3 bonds, and then you would just need to draw it more neat. So the nitrogen winds up with hydrogen atoms attached on the 3 other sides, and that's how you would draw NH3. So always try doing this connect the dot method first, because it's a lot simpler if you can do that, if you can accomplish that. Let's try one more. Let's do just O2, oxygen gas. So oxygen has 6 valence electrons, and there's 2 of them. So when we form bonds, we can attach them twice. We can't do anything with the lone pairs, but we can attach the electrons that are by themselves. So because there are 2 attachments between the 2 oxygens, we call that a double bond. So we would draw it like this, double bond, and then don't forget the extra lone pairs on the oxygen atoms. And that's how you would draw O2. Now, there's a few steps for drawing Lewis structures if they don't follow the rules. So if they don't work when you're trying to do connect the dots, then you would follow this process. The first thing you're going to do is count up all of the valence electrons for all of the atoms. Then when you start your drawing, you'll put the least electronegative atom in the center. All of the more electronegative atoms go around the outside. You're going to count up 2 electrons for each bonded outer atom. Then you want to fill in the valence electrons for the outer atoms so you have full octets. Remember, atoms like to have 8 valence electrons, so they're like a noble gas, and they have full s and p orbitals. If you still have any extra electrons at that point, then you will fill in the center one. And then finally, if there are not full octets, you will change lone pairs to double bonds. And we'll look at some examples of that. Okay, so let's start out with SF6. This one does not work with connect the dots. Sulfur has 6 valence electrons. Fluorine has 7 valence electrons, but there's 6 of them, so that's 42. So the total valence electrons, I have 48 for this molecule. Now, sulfur is less electronegative than the fluorine, so I'm going to put sulfur in the center, and I will put the fluorines around the outside. And each of those bonds represents 2 shared electrons. So 2, 4, 6, 8, 10, 12. I've used up 12 valence electrons there. I have 36 left. Now I'm going to try to fill in the octets of the outermost atoms first. Right now, each fluorine has 2 electrons. So the 2, they're just in the bonds. You can't see them because they're bound together. So that means each fluorine can hold 6 more to fill in the octet. So we have 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So that used up exactly 36 valence electrons. I don't have any left. If I did, I could put them on the sulfur in the center, but I don't have any more valence electrons. So this is my final structure. Okay, so for this example, which is xenon and 4 fluorine atoms, xenon has 8 valence electrons, and fluorine, there are 4 of them, and each one has 7 valence electrons. So total, I have 36 valence electrons. I'm going to put xenon in the center and draw my 4 fluorines around the outside. And so I just made 4 bonds with 2 electrons each. So I used up 8 electrons, and now I have 28 left. So I'm going to fill in the octets of the outer atoms next. Each fluorine has 2 electrons right now. It needs 6 more to reach a full octet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm left with 4 extra electrons. Those 4 extras need to go on the center atom. So I will have 2 lone pairs. And you can kind of squeeze them in wherever, because it's hard to show the 3-dimensional structure on a flat drawing anyway. So there is your XeF4.